Hi, everyone. So in this lecture, we're going to be going through some more examples on the disk and washer methods. And this will count as revision for your summative tutorial test this coming Wednesday. Okay, so I've just got a few examples of the disk method and the washer method just to help you out. Okay, so let's take a look at the first one. Okay, so we've got the following curve, y equals root x, and we are rotating about the x-axis from x equals 0 to x equals 1. Okay, so if we rotate this curve around the x-axis from 0 to 1, then we're going to get some solid shape, and we need to find the volume. Okay, so find the volume of the shape produced. Okay, so let's start off with a little sketch of what's going on. So we've got our axes, and we've got the curve root x from 0 to 1. So it looks something like that. So we're going to take this area here and we're going to rotate it around the x-axis. So we rotate it around the x-axis and we're going to get some solid shape produced. Yeah, it's going to look something like this. Yeah, so that's the shape that gets produced by rotating that area around the x-axis. Okay, so we want to find the volume produced. So to do that, we need to slice it up. So let's just look at what a slice looks like. Okay, so it's going to be a little slice like that with thickness dx and some radius r. Okay, and we can find the volume of that slice. And if we sum up all the individual volumes, we get the total volume of the shape produced. Okay, so that means the volume is going to be the integral from 0 to 1 pi r squared dx. Okay, so what's the radius going to be? The radius is this distance here. That's the radius. So the radius is going to be root x, because that's the distance at that point. So this is going to be the integral from 0 to 1 pi root x squared dx. So this is going to be pi integral from 0 to 1 of x dx. So that's going to be equal to pi 1/2 x squared from 0 to 1. So this gives us pi over 2 units cubed. Okay, so then that's the volume of the shape that's produced. Okay, so let's just look at that again. So we took the curve, we found the enclosed area. If we rotate that around the x-axis, we get this following shape here. Okay, we take that shape, we slice it up into disks. Okay, going along the x-axis, we find the radius of the disk, which in this case is root x. And then if we sum up all of the disks using this integral, we get the volume. Okay, so after this initial step here, then the rest is just simple integration, which we've done plenty of now. Okay, let's take a look at the next one. So this is example 2. Okay, so in this case, we have the following curves. Y is equal to x cubed. Y is equal to 8. And x is equal to 0. Okay, so that's all the curves. The enclosed region gives us some area, and we're going to rotate this about the y-axis. So rotate the enclosed region about the y-axis. Okay, and we need to find the volume. Okay, so let's go ahead and do that. So first we need to sketch everything, and then that gives us the region. Okay, so y equals x cubed, that's going to look something like this. X is equal to 0, but that's just this y-axis. Okay, so we got that line, we've got this line, and y equals 8, that's going to be something like this. Okay, this is y equals x cubed. Okay, and what is the intersection between x cubed and 8? That's going to be 2, because 2 cubed gives us 8. So what we want to do is now find the enclosed area. So that's this bit over here. We're going to take that enclosed area and rotate it around the y-axis. Okay, so if we imagine taking this red shaded area, we rotate it around the y-axis, we're going to get the following shape. Something that looks like that. Okay, so again, we need to slice it up into discs and then find the volume of a disc and then sum up those individual disc volumes. So if we make this into a slice here, okay, so just imagine that as like a disc kind of slice. Here's the axis going through the middle. It's got a thickness dy and some radius r. Okay, so what is this radius going to be? The radius is the distance from the y-axis to the curve. That distance there, that's the radius. In other words, the radius is the x value. So we need to solve for x. So if y is equal to x cubed, then x is going to be y to the 1/3. And that gives us our radial distance r. Okay, so we've got the radius, we've got the thickness, we can find the total volume. So the volume is going to be the integral from 0 to 8. Because remember, we integrate along the axis of rotation. So the axis of rotation is vertical, so we integrate in terms of y. So integral from 0 to 8, pi r squared dy. That's going to be the integral from 0 to 8, pi y to the 2/3 dy. Okay, we can take out the pi. Integrating this, we need to add 1 to the exponent. That will make it 5/3. Divide by that gives us 3/5, y to the 5/3. And this is going between 0 and 8. So this is going to be pi times 3/5 times 8 to the 5/3. Okay, so 8 to the 1/3, that gives us 2. So then we have 2 to the power 5 times 3 and then divide by 5. So that's going to give us pi times, and then the top is going to give us 96/5 units cubed. Okay, so in this case, the axis of rotation was vertical, which means we're stacking our discs vertically. So we have to integrate in terms of y. Okay, so when we stack vertically, we integrate in terms of y. When we stack horizontally, we integrate in terms of x. Okay, please remember that. Okay, let's take a look at another example. Example number 3. Okay, so we've got the following curves. Y is equal to x. Y is equal to x squared. Okay, so that's going to give us some enclosed region. We need to take this enclosed region and rotate it around some axis. In this case, it's the x-axis. So rotate the enclosed region about the x-axis. Okay, and then find the volume. Okay, so let's do a little sketch of what's going on, and then we can find out what the volume is. Okay, so the first line is y equals x. That's going to look like this. And then the second one is y equals x squared. That's going to be something like this. Sorry, let's just do that a bit better. Something like that. And this red region, the shaded in part there, that's going to be our enclosed region. Okay, so we need to rotate this around the x-axis like that. Okay, so what kind of shape is produced? Okay, well, if we rotate the straight line around the x-axis, we're going to get some kind of cone shape. Okay, but it's going to be hollow because this part here is not included. Okay, so it's not a solid shape anymore. Okay, so let's just remove that. Okay, so it's going to look something like this. So the straight line gives us some cone shape. Okay, but it's not solid because of this inside curve here. It's going to have something like this. Okay, and then it's open on the inside here. So this is open or hollow. Okay, because that part is not included. This red part that gets rotated around, that forms the walls of this shape. So that's that part there. Okay, so we want to find the volume of the shape. So since we're rotating around the x-axis, we're going to be integrating along the x-axis. So we want our x bounds. So the starting intersection here is at 0. And then this intersection will be at 1. Okay, because that's where the parabola and the straight line intersect each other. Okay, so we've got the bounds. Now we need to find the two radii, since we're dealing with the washer method in this case. So we have our inner radius here, and we have our outer radius there. So the inner radius is going to the parabola. So the inner radius will be x squared. The outer radius goes to the line. So that means the outer radius is x. Okay, so we've got the inner radius, we've got the outer radius, we've got the bounds of integration. We can then find the volume. So the volume is equal to the integral from 0 to 1 pi the outer radius squared minus the inner radius squared dx. Okay, so let's substitute. So this will be pi integral from 0 to 1. The outer radius squared is just going to be x squared. The inner radius squared will be x to the 4 dx. Okay, so we can integrate this. So that's going to be 1/3 x cubed minus 1/5 x to the 5 from 0 to 1. Okay, so let's substitute in and then we can solve. So this is going to be pi 1/3 minus 1/5, or we can write this as 5 minus 3 over 15. So that would be 2 pi over 15 units cubed. Okay. So in this case, we have some opening to our shape, or it's a bit hollow on the inside. And that's because we took an enclosed region between two curves and rotated that around an axis. So in this case, we need to use the washer method. Okay, where the inner radius was one of the curves, the outer radius was the other curve. And if we take the difference between those two, we get like the outer volume minus the inner volume, and that gives us this volume that I have here in red. Okay, remember, we're not including this inner part here. Okay, let's have a look at the next example. Okay, so this is example number, where were we? Example number 4. Okay, so find the volume. Find the volume. Obtain. By rotating the region enclosed bar y equals x and y equals x squared. Okay, so it's the same region that we dealt with in the previous example, but now we're rotating the same region, but about the axis y equals 2. Okay, so in the previous example, we rotated around the x-axis. Now we're going to take the same region, but rotate it around a different axis. Okay, so what's different in this case? So let's just draw a picture of the region, and then we can look at finding the radii. Okay, so we've got the following picture again. We've got the straight line part, we've got the parabola part. That gives us our enclosed region. Okay, like that. So we're going to take this enclosed region and rotate it around y equals 2. So that's going to be somewhere up here. Okay, because remember, this point here is 1, 1. Okay, so it's somewhere at the top there. Okay, so we want to rotate around here. So we need to find the inner radius and the outer radius. So how do we do that? Well, we know that this total distance here is 2. Okay, because from y equals 2 down to the x-axis, that's a full distance of 2. What we want is this distance here, which is r in. That's the inner radius. And we want this distance here, which is r out. That's the outer radius. Remember, we always measure the radial distance from the axis of rotation to the curve. In this case, the axis of rotation is y equals 2, so we measure the distance from there. Okay, so if we can find the leftover distance, these two distances in green, then we can find what that distance in blue is. In other words, we just do this on the side, r in plus x is equal to 2. Because we know that r in goes to the line y equals x, so that green distance there must be x. Okay, so that means the distance is going to be 2 minus x. Okay, what about the outer radius? R out plus x squared must also be equal to 2 because it covers the full distance. So that means r out is going to be 2 minus x squared. Okay, so that's that distance in blue there. Okay, and we've got the 2 radii. We can just use the formula to find the volume now. Okay, so remember again, we're rotating around a horizontal axis, so we integrate in terms of x. here the x bounds are still 0 to 1. So let's do that. So the volume is equal to the integral from 0 to 1 pi r out squared minus r in squared dx. So that's going to be pi integral from 0 to 1. Sorry, 0 to 1. R out is 2 minus x squared. So we have 2 minus x squared squared. And R in is 2 minus x. So this is going to be 2 minus x squared dx. Okay, so now we can just expand this out to get a nice polynomial, and then we can integrate. So this will be pi integral from 0 to 1. If we expand the first bracket out, we're going to get 4 minus 4x squared plus x to the 4 minus 4 minus 4x plus x squared dx. Okay, so it's going to be pi integral from 0 to 1. 4 minus 4, that goes away. So we're going to be left with x to the 4 minus 4x squared minus another x squared, that's minus 5x squared. And then we've got plus 4x dx. Okay, so this is just a polynomial that's easy to integrate. We're going to have 1 over 5x to the 5 minus 5 over 3x cubed plus 2x squared from 0 to 1. Okay, so if we substitute 0, we're not going to get anything. So we just substitute 1. That's going to be pi 1/5 minus 5 over 3 plus 2. Okay, so we can find a common denominator of 15. Add up the numerators, and we're going to get 8 over 15. And remember, units cubed. Okay, so that's how we find the volume in this case. So the only difference between this and the last example is we have a bit more work in finding the inner radius and the outer radius. But as long as you remember that the radius is the distance from the axis to the curve. So here, distance from the axis to the curve, that is the radius there. Okay. Okay, so the only difference in this case is we got a little bit more work here with finding the radius. Okay, but as long as you remember how to find the radius, the radii in each case, then it just goes back to the previous examples. Okay. Okay, we've got one more example to do, and then we can finish off for today. Okay, so this was example number 5. Okay, so we're going to take the same region as we have before and rotate around x equals -1. Okay, so take the same region. Sorry, let's write that a bit better. Take the same region as before and rotate around x equals -1. Okay, so same region, different axis. Okay, but the idea is still the same. We need to find the inner radius and the outer radius, and then we just use that formula to find the volume. Okay, so let's just do a sketch of what this looks like. Okay, so same region, so it looks like this. From 0 to 1, this is 0.11. Okay, so that's the region. Now we want to rotate around x equals minus 1. So that's somewhere over here. Okay, so we're rotating around this axis. Now it's a vertical axis. So what we want to do is find the inner radius and the outer radius. So this distance here, that's going to be our inner radius. And this distance to the outside, that is our outer radius. Okay, so we need to find what those distances are. Okay, so we know this distance here is x. And this distance here is 1. Okay, because we're going from -1 to 0, that's a difference of, that's a distance of 1. And from 0 to the line y equals x, well, that's a distance of x. Okay, so that gives us this radius there. Now remember, this is y equals x. Okay, so let's just fill that in here. So at this point here, this distance y equals x. Okay, so we can write this distance as y as well. Okay, what about this point over here? This is y is equal to x squared. But we want to know what the x distance is. So in this case, x is equal to root y. That's the distance over there. Okay, because remember the distance is x, but we want it in terms of y. So the x distance is root y. Okay, but we also need to add this 1 because we're measuring from the line x equals -1. So we have our in is going to be 1 plus y. Okay, because remember we have the distance 1 from x equals -1 to 0, and then the distance y from 0 to the line. And our out is equal to, again, the distance 1 plus root y. Okay, so we've got the two radii. We can now substitute and integrate. So the volume is the integral from 0 to 1. That's our vertical distance that we're integrating along. Okay, then we need pi r out squared minus r in squared dy. Again, it's a vertical axis, so we integrate in terms of y. So this is going to be pi integral from 0 to 1. R out squared is going to be 1 plus root y, all of that squared, minus r in squared, that's going to be 1 plus y, all of that squared. Okay, and then, of course, we need dy. So let's just expand this out, and then we can integrate. So this will be pi integral from 0 to 1. We're going to have 1 plus 2 root y, but we could just write that as y to the half, plus y. Okay, that's the first part. Now for the second part, it's going to be minus 1 plus 2y plus y squared dy. Okay, so let's just simplify that out. We have pi integral from 0 to 1. 1 minus 1, that's going to cancel out. Then we're going to have 2y to the half. Okay, plus y minus 2y, that's going to be minus y, and then minus y squared dy. Okay, this is easy enough to integrate. This is going to be 2 times. Remember, we add 1 to the exponent to make it 3 over 2. Divide by that, multiply by 2 over 3, but we've got this extra 2. So that's going to be 4 over 3, y to the 3 over 2, minus 1/2 y squared, minus 1/3 y cubed, from 0 to 1. Okay, so we're going to have pi 4 over 3 minus 1/2 minus 1 over 3 So 4/3 minus 1/3, that gives us 1. 1 minus a half is a half. So we end up with a half. Okay, don't forget the pi. So we have pi/2 units cubed. Okay. So again, very similar to what we had before. Just remember, if we move the axis around, we still need to calculate the radii from the axis to the curve. So here, Rn is the distance from the axis to the straight line. And the distance from the y-axis to the straight line has a distance x. But remember, we're working vertically. So we want the distance in terms of y. But y equals x, so the distance is y. For R out, we have the distance from the axis x equals -1 to the y-axis. That distance is 1. Then the distance from the y-axis to the curve, that little distance here is x. Okay, but we need to solve for x in terms of y. So if we have y is equal to x squared, then x is equal to root y. Okay, and then that gives us our 2 radii. Once we have our 2 radii, we substitute it into our formula, do the integral, and then we end up with the volume. Okay, so really not too bad. Just be very careful when the axis gets shifted around. Okay, you need to measure the distance a bit differently then. Okay, so if you have any questions, please let me know. You can email me or put a message on the class WhatsApp group. Okay, or you can ask the tutors for help as well. So their details are on the WhatsApp group and also on Learn 2022. Okay, the details are there if you want to ask for help. Okay, so this is it for the revision for your tutorial test on Wednesday. Tomorrow, which is Tuesday, okay, after the public holiday, we will then start the new section on using the shell method. Okay, and that will be the last method for finding volumes. Okay, we'll spend a couple days on that, and then we will move on to the whole new section, which is integration by parts. Okay, so that's the plan for this week. Okay, but if you have any questions for the tutorial test on Wednesday, please let me know.